All right, so picking up where we left off, so we talked about using correlation coefficients to make predictions. Next thing we can do is we can use them as evidence towards arguments for what we call validity. This is a much deeper word than people really understand. People use this term incorrectly all the time, including professionals that I know and love dearly. It's just sort of the way we speak sometimes, but it's a word that's a little bit complicated. Now, in its essence, validity, when you boil it right down, is really asking about our interpretations of our results. When we're talking about validity, what we're really talking about is, do we correctly and accurately have an understanding of what the results are trying to tell us? Remember that the numbers are just numbers, calculators are calculators, but we have to really think about what this stuff means. It's why we're learned all those mantras that we have to learn, because it's part of evaluating and understanding what we're looking at. So validity in its broadest sense is asking, are we correctly understanding and interpreting our results? Now, what has to be in place in order for that to be answered yes, that we are correctly interpreting, is that our measurement procedures actually have to measure what we think they're measuring. I know that sounds weird, but if I'm trying to measure depression and I say, oh, I'm going to go get this test to measure depression, the only way I can accurately make an interpretation about your level of depression or not is based on the assumption that this test I gave you really does measure depression. If it turns out the thing really measures anxiety, even though it says depression test right on it, right? If it's mislabeled, if it's badly designed, well, I can't give a bunch of questions about anxiety and make correct interpretations about depression, right? If I want to measure your intelligence and I go get an intelligence test off the shelf, it says IQ test right on it. But are the questions on that test really measuring depression or not? What if it's just a lousy test? If I'm not really measuring intelligence with that test, then how can I draw any correct conclusions about your intelligence? If I'm not really measuring depression with the test, how can I draw any conclusions about what I'm measuring? So one of the things correlations can help us somewhat with is trying to establish, does this measurement test, this procedure, really measure what we think it measures? So there's a few ways of doing that. So let's say you're going to invent your own questionnaire to measure intelligence. I'm sorry, let's go to depression, it's easier. You're going to come up with your own set of questions to measure depression. So you have your student depression rating scale. Well, the first thing you're going to have to do is to prove to the rest of us on the planet that your test really measures depression. And you can't just say, it does because I said so. You have to provide an argument for that. You have to provide some evidence for that. And the way you would typically do that is you would go get an established test that people already accept as being legitimate. So let's say the Beck's depression inventory. So you have your depression inventory and you have the Beck's depression inventory. Give them both to a person. See how they score on Beck's, see how they score on yours. If they score as highly depressed on the Beck's, they should be coming out as highly depressed on your test. If they come out as low level of depression or not depressed on the Beck's, then they should come out with low level on yours. So notice that we would expect a positive correlation there. So in doing so, we're saying, look, the results we're getting are similar. Therefore, my test must measure the same thing that test measures. Therefore, my test really does measure depression or whatever it is. The opposite way of doing that is to prove that your test does not measure what the existing one does. So you've written your own depression test and I look at it and I go, you know, that seems more like an anxiety test to me. Prove to me it isn't measuring anxiety. Well, go get a pre-existing, already accepted by the scientific community anxiety test, give them that test, then give them your depression test. There shouldn't be any relationship between those two things. Someone's score on anxiety is unrelated to their score on depression. So we would expect to not have a relationship there. We would expect to fail to reject, if you will. So that would show us, oh yes, this really does not measure anxiety. So it's what we call concurrent and divergent validity. We don't need to get into that level of technicality. But that's one of the things we can do. We can try to see, does this measurement procedure really measure what we say it does based on how it patterns with other tests we already like. Third thing on here is reliability. Reliability is a much more straightforward concept than validity. Validity is about having accurate or truthful interpretations of your results. Reliability is simply about consistency. Do we find consistency? Now, there are many specific types of validity. There are also many specific types of reliability. So, but on the whole, with reliability, we're asking, are the measurements we're getting consistent? And one of the ones we look at most often is called stability reliability. Pardon me. This used to, back in the day, be called retest reliability, which I kind of like that name better. I measure you, I wait a while, I re-measure you. If you haven't changed, your score shouldn't change. If I give you an IQ test today and you score at 120, well, if I go back to you 2 months from now, assuming you haven't changed, you should still score pretty close to 120. If you scored high the first time, you should still be scoring high. If you scored low the first time, you should still be scoring low, mid for mid, right? So that would be stability reliability, or test retest, getting consistent results over time. Measure you, wait time, measure you again. Assuming you haven't changed, your score shouldn't much change either. So we could show that our tests are stable over time as the third thing. Lastly is what your text calls theory verification. And really, had I thought of it today, I would have just put it right up here with predictions. It's basically the exact same point. Many theories espouse connections between variables. Sometimes it's cause and effect, and sometimes it's just related. We've noticed patterns. People with these characteristics tend to be vulnerable to these types of issues, or people with those characteristics tend to be more resilient in these sorts of situations, whatever that might be. It's really about predicting again. The theory predicts that these characteristics or traits will be associated with those characteristics or traits. So it's really just taking this idea of prediction again, but the prediction is specifically coming out of a theory. So they're really almost synonyms. So we're listed as 4 things here, but 1 and 4 are very, very closely related together. So those are the 4 things that we commonly use correlation coefficients to do. So that part is done. Off to the next.